Let's look at the average value of a function. The average value of f of x on the interval from a to b is the integral from a to b of f of x dx all over b minus a. Why? The area divided by the width tells us the average height of the function. Here's what I mean by this. So suppose we have this function y equals f of x, and this is our interval from a to b. Okay. Notice that the numerator is going to be the area of this region between y equals f of x and the x-axis from a to b. And the denominator is just going to be the width of this interval from a to b. So it seems reasonable that if you divide the area by the width, you get the average height. Because, for example, if you take the area of a rectangle, if you divide the area by the width, you end up with the height of the rectangle. And so in the same way, if you divide the area of this region by the width of this region, you get the average height of the function. Seems reasonable. For example, find the average value of f of x on the interval f of x equals sine x in the interval from 0 to pi. Okay, so f of x equals sine x in the interval from 0 to pi. Again, here's the formula we saw earlier. Average value is going to be the integral from a to b of f of x dx over b minus a. In this case, f of x is sine x, and our limits of integration a and b, those are going to be in 0 and pi. So 0 and pi, and then we have pi minus 0 on the bottom, b minus a. So the 1 over pi minus 0 becomes 1 over pi. The antiderivative of sine x is negative cosine x. We evaluated at 0 and subtract what we get. We evaluated at pi and subtract what we get when we evaluated at 0. So we end up with 1 over pi times 1 minus 1 over pi times negative 1. Those are the values of negative cosine. In other words, 1 over pi plus 1 over pi, and that's 2 over pi. Does this seem reasonable? Here's the way the book looks at it. I'm not sure how helpful it is, but this is the graph of y equals 2 over pi. Okay, so does it seem reasonable that the average value of this function would be about 2 over pi? Yeah, I guess so. I guess on average the height of the function is 2 over pi. That seems reasonable. Find the average value of f of x equals x cubed on the interval from negative 2 to 1. Okay, so same story. We evaluate the integral of x cubed as x goes from negative 2 to 1 dx, and then we divide by the width. So we end up with 1/3. The antiderivative of x cubed is x to the 4th over 4. Plug in 1 and negative 2. When we plug in 1, we get 1/3 1 over 4 minus 1/3 negative 2 to the 4th over 4. That's what we get when we evaluate it at negative 2. So this is going to be 1/12 minus 16/12. In other words, negative 15/12, which simplifies to negative 5/4. Okay, so does this seem reasonable? This is y equals negative 5/4. In other words, y equals negative 1.25. Is that the average value of the function? Yeah, I guess that's the average value. That's the average height of the function. Notice that in this case, because there's so much of the area, because the function is predominantly under the x-axis, it's not a surprise that the value of the function, it's not a surprise that the value of the function is going to be, is going to be negative on average, because so much of the function is negative here, and here's the portion where it's positive.